Okay, and that's it for equations. The last thing we want to talk about is linear systems, and that is where do two lines intersect, the POI. That's a solution to a linear system. I have two lines, and where they intersect, we have a point of intersection, or what we call a solution. So that's we're going to go over some word problems, which will make a lot of sense out of this. But if we don't have word problems and we just have lines, what you do is you plot the lines, and what you'll find is if you take your time and you graphically plot them, you'll end up finding the point of intersection. In this case, it's 4, 6. Another thing that is true is if you go ahead and you make a table of values for this line with x and y, what you'll find is that the points 4, 6 will end up on both the x and the y. Sorry, the 4, 6 will end up in both this line and this line. Okay, so eventually, when you make a table of values, you'll find those points on both tables. Okay, so that means that if you find both points, that means they exist on both lines. So think about that for a second here. If a point exists on two lines, that means when I draw the lines that they'll both go through those lines, which means that if you draw the lines in their entirety, that means they'll meet at those two lines. Okay? Not always is there a solution, right? Because you can have parallel lines, and parallel lines will not have a solution. So usually you have one solution. Sometimes you have an infinite number of solutions. So if I draw a line, I draw another line, and they end up being the same line, but I didn't know that, they lie on top of each other, then there'll be an infinite number of solutions for those two lines. It's a special case, but let's just do an equal. Oh, we have an announcement. I don't know if you can hear that. Let's go. This blue I can't really see, so let's look at this one here. Let's go through this here. So what I have here is this guy and this guy, and we're going to say do they intersect. First thing I want to do is rewrite this. I don't like that way. I want to write this as y equals mx plus b form, so I'll bring the x over, and I end up with this. And then this one is this. And we can go ahead and make a table of values for both of them if we wanted to see that they, in fact, intersect. But instead what we'll do is we will graph them and then see what happens if they'll run into each other. And then from there we'll see if we can prove that this is, in fact, true, that there is a point of intersection. So here I have this line here, and it has a b of -3. And then to find the next point, I want to go over 1 up 2. Okay, but the other thing you can do is note that you can go over 1 up 2, or you can go over 2 up 1. Okay, so we've done this before, where there's my slope. I go over up a half, and I keep going like this. So basically every 2 I go over, I go up 1. So I'm going to be careful here. So I go up 1 over 2, up 1 over 2, up 1 over 2. So I'll end up here. Up 1 over 2, up 1 over 2, and I'll draw my arrow like this. This guy here, and then going this way, let's just keep going. That, there, and that, there. This guy here has a y-intercept of -6. Actually, to tell you the truth, I should change that color. So this one here I'll do in red. I have a y-intercept of -6, and I have a slope of -x, which means I go over 1, down 1. And what you'll notice here, if you draw this, that my point of intersection is going to be up here somewhere. So I got to be careful here. That guy there, that guy there, that guy there. It looks like the point of intersection is right here. And this will be the point -2, -4. So -2, -4. And you ask yourself, is this true? Is this the right answer? And it'll be the right answer if it exists on both lines. So to do that, what we do is we sub in this point. We can sub in this point into both equations to see if it holds true, or do a left right side check. So what I do here for equation 1 is I have y equals 1/2 x minus 3. And I ask myself, does this point lie here? Or is it true? Another way to ask this question is I made that, this should be purple. This is my purple line. Y equals little pop up there. I don't think you guys saw that. Pop up the news. 1/2 x is then going to be 1/2. Sorry, this is my x and my y. 1/2 times -2 minus 3. Does that in fact equal -4? So 1/2 times -2 is -1/2 minus 3. -4 on the right, -4 on the left. Yep, we're good. So this point, -2, -4 is on my first line. And let me go to the red line here. Is it on the red line? Is it on y equals minus x minus 6? That would be true if this is true. Is that true? No, it's not, because I intersect. Good. Is this true? Minus 4 minus 6. This one's tricky. So minus 4. Minus 4 is plus 4 minus 6. Minus 2 equals plus 4 minus 6. Minus plus 4 minus 6 is minus 2. Left side equals right side. Yeah, we're good. Okay, so that is a system of linear equations here. And we ask ourselves, do they intersect at this point? What you'll do, so let's just do this one here. Do they intersect at this point? Y equals 1/2 x. Is that point on that line? So what you're going to do here is you're going to say, is it true that 1/2 times 6 equals 3, because that's x and y. 3 equals 1/2 times 6 is 6/2, which is 3, so that's true. Is it also true that it holds, that it's on this line, sorry, that this point is on this line? Is it true then that 3 equals -5/2 times 6 plus 1? Is that true? So the math on this is a little complicated. This is where we really got to work on our multiplying here. This is minus 30 over 2 plus 1. And is that going to be true? Minus 30 plus 2 is, in fact, minus 15 plus 1, and that's not going to be true, right? That's way too big. So no, they don't intersect at this line because the 0.63 does not. The 0.63 is not on this line here. If it's not on the line, then they can't intersect at those lines. Okay. Now, do they intersect? They might. Okay, but they don't intersect there. This one here, you're looking at this one. You want to eyeball this guy here. Do these guys intersect here? Well, real quick, you can go ahead and play around with this, but you go, wait a second, what's going on? These guys have 2 and a 2, and you say, what's up with that? Parallel lines have the same slope, and they won't intersect ever. So you could cut that guy short and just say, no, they don't intersect. So then we get to the word problems, right? So the word problems are going to be where this really is interesting. So we have 2 different things. We have Mike is considering joining a golf club. One is that it's $50 per day. Another is $40 a day with $100 up front registration fee. Okay. So what we have here is we have variables, we have the cost, and then we have the number of days. So they define the variables for us. So we have 2 equations here. We have the standard rate and the frequent extremis. That's kind of aggressive, but let's go with that. The standard rate is then I have a cost that is $50 per day. So it's $50 per golfing day, okay? So it should be per golfing day kind of rate as each time you go golfing. So $50 times n. So I just go $50 per golf day, I guess. So $50, 50 times n is going to give my cost, right? So if you go once, it's $50. You go twice, it'll be 2 times 50, 3, et cetera, et cetera, et cetera. This guy here, my cost, okay, so equation number 2, you're going to have a cost that is going to be $40 times n, $40 per day, plus $100, okay? Now that is going to be here, let's go over this. This guy here is going to be your direct variation. This is going to be partial, right? Because you got a little piece here that's extra. You plot this one here, 0. Okay, so if you want to plot this, you can make a table of values, right? So I have C and I have N. And the first one here, what I do, I have N, my fault. I have N and I have C. And what I say is if I don't go golfing ever, I don't pay anything, okay, for the first one. So this is SR. So SR, I have 0 and 0, and I have 0 and 0. If I go once, then I go 50 times 1, which is 50. So the point 150 is there. So I ran out of space here, but let me just redo this. I have N and C, 0, 0, 1, and 50. My next one, if I did this here, if I went 2 and 50 times 2, that would be 2 and 100. So all these points here, so that's that guy right here, and then you go like this, and you graph it like this. And this one here is going to be a little bit different. I'll do it in a different color. So we take our time with this in class, but you end up with N and C. Okay, so remember this is X and Y, independent, dependent, right? So if I don't go golfing ever, I have 40 times 0 plus 100. I still have to pay $100. Okay, because this here is 40 times 0 plus 100, which is 0 plus 100, and I'm stuck with a $100 fee. If I go once, this becomes 40 times 1 plus 100, which is 40 plus 100, which is 140. So we would take a little more time on this, but I don't have any space or as much time. So that's 40 times 2 here would be 80 plus 100. So this would be 180. This is going up by 40. So this one here, what's my first difference here? That's 50. That's 50. That's 50. This one here is 40 and 40 and 40. Okay? So I have a slope here. My slope is 40. My slope is 50. This is steeper. This one is less steep, but it starts at 100. So usually when we do questions like this, one is going to be steeper than the other. The one that's steeper is the one that starts lower. Okay, that's just the way we usually do them, so they can intersect at an appropriate value. And if I plot these points 1 and 140, and I keep going, and I go, well, these are really hard to look at. I might keep going, and if I get 5, for example, if I go 5, I put a 5 here. I get 40 times 5. Sorry again for how ugly this is, but 40 times 5 is 200 plus 100 is 300. So I'd have this nice point here, 5, 300. Okay, take your time with this stuff. No, that's not 5. That's 5 there. 5, 300. So I plot this one. It looks like this, and then you keep going, and then at 10, you're going to see that at 10 times 40 is 400 plus 100 is 500. I'm right here at 500. And if I took my time, I'd realize that's the point of intersection, is the point they intersect at the point 10, 500. And you ask yourself, is that true? Well, what's it mean, first of all? That means that in 10 days, I pay $500 regardless of which one I use. If I use this guy or if I use this guy, okay? Now, if I use the first one, the one I have in red here, it's going to be cheaper initially, but if I golf a lot, it's going to be more, right? Because I'm paying $10 more per round. So basically what you're saying is that 10 golf days, you're paying $500 regardless of if you do the I'm paying nothing down or if I'm paying $100 down. Either way, you're going to end up here. On the left here, so if you golf less, then this guy here, the red guy, will be lower, which means that he's cheaper, right? So this red guy, the initial red guy here, is the direct variation will be cheaper. And then after they intersect, then this one here ends up being less, okay? So what happens is this one is more because I'm paying the $10 more each time, and as I keep going, like just think of this in extremes. If I went 1,000 times, I'd pay $50,000 here, and I paid $40,000 plus 100 here. Okay, so this one's going to be higher if you go lots of times, right? And what happens is they cross at 10. Okay, that's the point of intersection. Anywhere less, if you go less than 10, then the SR is cheaper. If you go more than 10, then the FE is cheaper. Okay, and then we could just talk about that in words and go from there. Okay, just take your time. How do I know this is true? The 10, 500, I could sub it into both equations and prove that it's true. For SR, what I would do is I go 500 equals 50 times 10, and that's going to be a quick one. That's 500 equals 500, I'm good. And then for FE, the second equation here, what you would do is you would say 500 equals 40 times 10 plus 100, okay, the point 10, 500. 40 times 10 is 400 plus 100 is 500, so 500 and 500 is true. Sorry about that, guys. 500 equals 500. That is, in fact, also true. Okay, so that's that. Next year you're gonna be solving these guys using algebra, which is gonna be really cool. But at this point, we'll just solve graphically, and then after we solve them graphically, we can then go ahead and sub both points into each equation. And if they're both on each, if the point is on both lines, then they happen to intersect at that point. So then after that, that's about it. Isn't that amazing? We're all done. Okay. That's it, right? And then, like, I'm just looking right here. I got a little distracted. What would you recommend to Mike? You would say, hey, Mike, you going to golf a lot or not? If you're going to golf a lot, then you want to go with this guy, the frequent extremist. Okay, it gives it away kind of with the name. If you're not going to golf a lot, then you want to go with this one where you don't put down the $100 off the bat. Okay, so that's it. That's all she wrote.